much for entertaining me. I've been here for most of the week, and firstly, how impressed I am from going around some of your sites. Your country is beautiful. The people here are fantastic. You should be immensely proud, not just of your country, but your whole industry. Sorry? Springboks. Yeah, you can be proud of your rugby team as well. That's a really good British sport, that. So yeah, lean into that. My heritage, I'm from Cornish mining background. You may have heard of Cornwall, and everybody knows the Cornish are the best miners in the world because they were all trained by South Africans. So thank you also for the Cornish pasty. That's another British product that most of you are aware of, and again, best. The Brits are best at stealing other things from other countries, so thanks again. No, really, I'm so humbled to be here actually, and thanks for the introduction, but you really should be very proud of what you do here. It's been really enlightening to come and see. I did wonder, why on earth am I coming over to South Africa to talk about blasting? And what was quite obvious when I came was actually you're facing the same issues that we're facing over in Europe.
When we're talking about air overpressure, we're on infrasound range. It's not audible, hence why we should be talking it in terms of Pascals. You can't cause damage to hearing in terms of the levels that we're at. In terms of from a blasting, you're much, much higher. So a typical air blast frequency is below 10. Typical building kind of response frequency, you're looking around 8 or so, depending on the structure. So it's actually quite important that we keep the air blast frequencies very low. Humans can't hear frequencies below 20 hertz, so you can see we're outside of that range. So the other part to this though is with the air blast we get the audible sound, and that can cause alarm in terms of how you hear it. But they are two different measurements, and you actually need two different microphones to do it. So it's a plea to say, please stop using decibels when you're quoting air overpressure. It's a source of major concern and confusion with communities. So we've gone and obviously done internal monitoring properties. You don't normally do this, it's much you don't need to do this, it's just we're kind of going to build up the scientific database. So again, you can see the microphones and the setup that we've got in terms of trying to explain to the general public what's going on with their buildings. The photograph in the centre here, you can see the two mics in there to pick up the air overpressure. So this is the Instant Cell Micromate Plus, which some of you might have seen. So this was the beta testing on that system done. It's now up for general release. So if we're thinking about air blast being the cause, this is a really controlled experiment within a building. And what we can see is in blue here, that's the building response. White is the ground wave. So you can see the ground wave goes through, not much building response. But as the air wave comes and here's the air blast hits, you can see we've got a massive building response from it. Now, if we then look at the audible sound, you can see the audible sound on this blast came with the air blast. So you can see suddenly this is evidence-led community engagement. You're in someone's house, you can demonstrate what's going on. So this has worked wonders in the UK where air blast has been the cause of concern, because you can then direct that and relieve. Community will often ask, say, okay, that's for one blast. What happens if you do hundreds of blasts and we have what we call cyclic loading or fatigue damage? Now, because we know when crack initiation starts, and this is micro cracks, it's not proper damage, we know that point, we can say, actually, you're fully within the elastic limit and you're safe, so you will not get fatigue damage from there. The peak strengths against your vibrations were orders of magnitude apart, and the British standards tells you this. They actually qualify that and say there's little probability. The reason I say little probability is because you just can't say there never will be. But basically that's saying there is no risk of fatigue damage because we're so low in terms of the yield strength and the ultimate strength. It's just pure physics. It's good rock mechanics. Okay, air blasters have been touched on. Again, British standard, great place to go to because it just puts that to bed in terms of what the safe limit from an air blast is. In terms of talking to the communities, we tend to turn it into wind speed, and we can say all buildings are designed and you've experienced high force winds, and therefore wind is far greater impact than the air blast. It will cause those standing wave nuisance, but don't confuse that with the damage effect from a property. So the next part of that was like, great, how do we improve on what we're doing at the moment? So we were looking at some historic vibration data, and you're probably used to this, you've seen some of this elsewhere, and the quarry manager didn't know whether his peak PV at the property was going to be the 1 or 10 milliseconds. You've got a whole order of magnitude, which